Hello, this is video 2 of 4 types of septic systems as part of our homeowner video series. I am Mary O'Leary, a professor in the Civil and Environmental Engineering Technology program in the Engineering Department at Vermont State University. A reminder about why we care about wastewater treatment systems at all. The first reason is for protection of human health. Waste has bacteria, great bacteria that helps, and then bad bacteria that can be a problem. The bad bacteria are pathogens, bacteria, viruses, and other microorganisms that can cause disease in humans if humans come into contact with the wastewater. Another reason we care about wastewater treatment systems is its impact on the environment. Ill-functioning wastewater treatment systems can negatively impact the environment with pathogens or excess nutrients that can get into groundwater or nearby water systems. Why a specific type of system is chosen for individual sites? The system's design must take into account these factors. First, the daily wastewater generated from the site. This is based on the number of bedrooms in a residence, or the number of seats in a restaurant, school, or the number of sites at a campground. It's also dependent on soils at the property. This is really important. All of Vermont's on-site wastewater treatment systems are soil-based. It also depends on the depth to groundwater or bedrock at every site. Other characteristics of the site also play a role, such as building locations, water supply locations, slope of the land, and property boundaries. A reminder on how do soil-based wastewater treatment systems work. It all starts in our stomachs with digestion. We have good microbes that start digesting all of our food, and all of that is extruded as waste through the piping that goes from your toilet, your showers, and your sinks. That goes into a septic tank outside your building where there are anaerobic bacteria, so without oxygen. Those microbes start to treat the wastewater and the sludge that's in the tank. Then the wastewater is sent to a distribution box and into the leach field or dispersal field, where aerobic bacteria, that's bacteria that likes oxygen, continues to treat the wastewater as it filters through the sand and gravel and into the soil. Components of an on-site wastewater treatment system. Traditionally, these include a septic tank, and then the soil-based treatment system, that is a dispersal field, also called a leach field, and the associated piping between the house, the tank, and the dispersal field. The components of an innovative and alternative system, IA systems, can include an extra tank between the septic tank and the leach field, or different material in the dispersal field. Some IA systems have everything in one large buried structure. These IA systems are used for small and challenging sites, high-strength wastewater, or treatment of specific compounds in the wastewater. All of these systems are soil-based. On-site septic systems can be in-ground, those are gravity-fed, or pressurized using a pump. The pressurized systems can be at grade, so right at ground level, a mound system, or an IA system. Septic tanks can be different for a traditional system, as shown in one of these pictures here, which shows the baffled system, how the solids sink to the bottom, the scum, the fat soils, and the grease rise to the top, and then the wastewater is in the middle, and that gets sent out to the distribution box and the dispersal field. IA systems can sometimes have different material in the septic tanks, or an additional tank after the septic tank that does a lot of the treatment. Dispersal fields or leach fields. These can be a trench with pipe and stone, that's gravity-fed. In some cases, this can be a bed, which is just really a wider trench. For IA systems, different materials can be used in the dispersal field, including geotextiles, polyfiber chambers, mats or pods, or compartments using algae, recycled glass, cocoa fibers, or peat. Dispersal field size and shape. There are rules for the depth of soil needed below the dispersal fields to a groundwater or bedrock. And this is sometimes why a mound is needed. This depth varies based on whether your system is pressurized or not. Leach field width and length vary based on flow designs, soils, or use of an IA system. For example, use of an IA system can significantly shrink the size of the leach field you might need. These are examples of soil-based innovative and alternative dispersal systems. These include large diameter aeration and infiltration chambers, replacing traditional stone and pipe. All IA systems require regular inspections by approved professionals. These are examples of IA treatment systems. So on the one aerobic treatment units, there are bubblers that somehow inject air into the system, either from the top, from the bottom, or from the side. Then we also have alternative media filters, and that uses organic materials like cocoa husks or peat materials or algae. For all of these systems, we are counting on that soil below the dispersal system. Now, this picture that you're looking at is pretty exaggerated, but we do depend on a certain amount of soil before it hits groundwater or bedrock to allow for continued treatment of the wastewater after it goes through the dispersal system. This is why we call Vermont's system soil-based. We're also counting on the maintenance and proper use of all of Vermont's on-site wastewater treatment systems. Be septic smart. Be sure you know what maintenance is necessary for your system. For a traditional system, have your septic tank pumped out every 3 to 5 years. Check on and clean the filter if necessary twice a year, depending on use. If you have an IA system, it must be inspected and maintained biannually or annually by an approved service provider. And keep good wastewater habits. Don't overload your system or dispose of non-domestic wastes in your sinks or toilets. Thanks for watching. This video series for homeowners was developed through a Lake Champlain Basin Program grant to the Wastewater System and Potable Water Supply Program of Vermont's Department of Environmental Drinking Water and Groundwater Protection Division.